All right, calculus students, here we go. So we know how to take the derivative of products, quotients, composite functions, right? We have the chain rule. We also know how to take the derivative of implicit equations, right? Implicit differentiation. So we kind of covered those big three rules and another technique that's super helpful for us. As we've talked about in class, though, we still have a lot of functions that we need to know how to differentiate. And today we're going to start with the natural log function. So what is the derivative of our natural log function? So let's say we have just y equals the natural log of x. What is its derivative? Well, let me first think about what I expect it to look like. What's the graph of the natural log of x look like? Okay, we have that vertical asymptote, and it comes up like this and grows that way, right? That's the natural log of x. Okay, so let's call that f. Maybe they'll call this f of x over here. All right, so there's f. What would its derivative look like? Well, over here I notice that the slope is super positive, right? Really, really steep. So the derivative has to start up high. And then as we go further and further to the right, as x increases, the slope decreases and gets closer and closer to 0. Now it's always growing, so it'll never get to 0. So I'm expecting a horizontal asymptote at y equals 0 for the derivative. A vertical asymptote at x equals 0. Okay? And of course, the derivative shouldn't exist on the left side. So I'm expecting f prime. Oh, grabbing word to look something like that. And I want you to think for a second, do you know any functions that look like this? Have a vertical asymptote at x equals 0, horizontal asymptote at y equals 0, and it starts up high, comes down, and gets closer to 0 as x increases. Maybe you do. This is a video, so obviously you can't tell me, but I want you to hold that thought as we figure out the derivative. Now, I could go back to the definition of the derivative and say f prime of x is the limit as change of x goes to 0 of the natural log of x plus change of x minus the natural log of x over change of x. I could do that. But even just looking at that right now, I don't know how I'm going to get this change of x out of that logarithm so that we can cancel it with the bottom. I'm not sure where to go. So let's scratch that idea. And let's ask ourselves, is there anything we know about taking derivatives here that could help us? Okay. And there's a reason that we haven't done this until our most recent section on implicit differentiation, right? Y equals the natural log of x. Remember, what does that mean? What's the definition of a logarithm? It means that we have some base of an exponential there, it's base e, and if y equals the natural log of x, then e to the y equals x. Now, why would I do that? Because I know the derivative of e to the y. We can differentiate this with respect to x. What is the derivative of e to the y with respect to x? Implicit differentiation. The derivative of the inside is y. The derivative of the inside is dy dx. Times the derivative of the outside at the inside, that's e to the y. Right? The derivative of e to the y with respect to x is dy dx times e to the y. Equals, what's the derivative of x with respect to x? 1. Solve for dy dx by dividing by e to the y on both sides. So we have dy dx equals 1 over e to the y. But do I want my differentiation rule to have a y in it? No, I don't. But what do we know about e to the y? E to the y is x. That's the derivative of the natural log of x. The derivative of the natural log of x is 1 over x. Isn't that what 1 over x looks like? Doesn't it look like this? Now you're also right that 1 over x has this branch of the graph over here. So there's one thing that we do have to remember and be careful at times, is that the derivative of the natural log of x is 1 over x, but it's only for values in the domain of the natural log of x. It's only true for x's that are greater than 0. Okay. So our rule, okay, is the derivative of the natural log of x with respect to x is 1 over x. It's a pretty simple rule. Hey, let's get to examples. Take the derivative of the natural log of 2x squared plus 1. This is chain rule, right? My inside function is 2x squared plus 1. My outside function is the natural log of x. All right? So what's the derivative of the inside? 4x. What's the derivative of the outside? The derivative of the natural log of x, well, we just said that's 1 over x. So let's put it together. F prime of x is the derivative of the inside, 4x, times the derivative of the outside, 1 over x, but chain rule, what do we have to do? We have to take the derivative of the outside with the inside still in it. So it's 4x times 1 over 2x squared plus 1. I'll just write that as 4x over 2x squared plus 1. Good? All right. Let's try another one. X times the natural log of x. Okay, x times product rule, right? Let's do our product rule. First times the derivative of the second, plus the second times the derivative of the first. Clean it up. X times 1 over x is 1, and then it's just 1 plus the natural log of x. Kind of a simple function for the derivative. Ooh, chain rule, composite function. Our inside function is the natural log of x. Our outside function is the natural log of x. What's the derivative of the inside? 1 over x. What's the derivative of the outside? 1 over x. So let's set up our chain rule. Derivative of the inside, 1 over x, times derivative of the outside, 1 over x. But we have to do the derivative of the outside with the inside still in it. So it's 1 over x times 1 over the natural log of x. So f prime of x is 1 over x natural log of x. Nice. Very nice. Ooh, chain rule again on this one. Inside function, square root of x plus 1. Outside function, natural log of x. The derivative of the inside. Ooh, I have to use the chain rule here. Okay, this is a chain rule in a chain rule. However, the derivative of this inside, the derivative of x plus 1 is just 1. The derivative of the outside at the inside here would be 1/2 x plus 1 to the negative 1/2. So remember, the derivative of the inside here is just 1. I didn't write it, but that's what it is. Derivative of the outside function, 1 over x. So, chain rule. Derivative of the inside. Oh, did I lose something? I think I lost something up here. There we go. derivative of the inside is 1 over 2 square roots of x plus 1 times the derivative of the outside, 1 over x, but we need to put the inside back in, like that. This is really 1 over 2 times x plus 1, right? Square root of x plus 1 times square root of x plus 1 is x plus 1. Now I know what you're thinking. You're thinking, Mr. Mayor, I remember doing lots with logarithms last year. And one of my favorite things about logarithms were all those properties that we had. That's what you're thinking, right? Isn't the natural log of the square root of x plus 1 just the natural log of x plus 1 to the 1/2? And then you see that 1/2 exponent and you remember, hey, in logarithms, if I have an exponent, what can I do with that exponent inside the logarithm? I can bring it to the front. Aha. What's it look like to take the derivative this way? Well, I can leave the 1/2 in front. Now the derivative of the natural log of x plus 1, it's still chain rule, but what's the derivative of the inside? 1. The derivative of the outside is 1 over x, but we got to put the inside back in, which is, aha, look at that. Same thing. Don't forget your properties of logarithms. Let's look at one more example. What could I do with this? Now, I could use the chain rule, and the derivative of the inside would require the quotient rule, but then I spot and say, hey, I have a quotient inside a logarithm. Isn't that the same as dividing in a logarithm is the same as subtraction between logarithms? No more quotient rule. Now, I still have to use the chain rule, and I hope it's okay if I skip the steps of writing inside and outside. What's the derivative of the inside of the natural log of 2x? Well, the inside is just the 2x parts. The derivative of the inside is 2. Times the derivative of the outside. Well, the outside is the natural log of x, so it's 1 over x, but put the inside back in, so that's 1 over 2x. Minus the derivative of the inside over here is just 1. The outside is the natural log of x, so it's 1 over x, but put the inside back in, and it's that. Doesn't this seem a lot nicer than doing the chain rule with the quotient rule inside of it? So, one new rule today. The derivative of the natural log of x is 1 over x. Other than that, you are still using product rules, quotient rules, chain rules like before. Good thing we're good at those, right? But don't forget, what are other things you know about logarithms? You know how to use properties of logarithms to rewrite, to expand and condense, like we did last year. All right, this is a great start to one of many more functions we need to find the derivative of. Thanks for watching. We'll see you later.